So how would you feel if you weren't able to see? Obviously, these people might feel cut off from society, and that is why we've chosen to create Eye-Nghin, which is basically a bionic eye, which is surgically implanted and is used for people who are blind but have a damaged eye and a fully functioning optic nerve. So now we're going to tell you a bit how Eye-Nghin works.
So this device works by reflected light entering a camera here, and then there is also an image is created, and that image is then transmitted through a wire into a microchip. Then that image is sent through Bluetooth and to a mobile app, which then turns this image into data, which turns and sends this data to this microchip, which then can be used by this transducer to stimulate the nerve cells and create an image.
This eye is 21 millimeters wide, yes, and in length it's between 25 and 27 millimeters, depending on how big the eye is. The camera is in place of the pupil, and it's 1 millimeter in the diameter. Same with the sensor. The sensor is used so when that person who has this bionic eye closes his or her eyes, or eye, because it could be used for even both eyes, it will send a signal to the microchip and it will shut off the system, saving more battery. These are wires which are wrapped in silicone. Everything here that could damage the person that has the bionic eye is wrapped in silicone, although it's covered, the main body is covered in glass, so that shouldn't really be a problem, but still extra precaution for extra safety. This wire will then send the signal to this microchip, which will then shut off the whole system. Then, to start it again, this sensor, the only thing that will not be shut off would be the sensor, so it can pick up again when light is present. There is a lithium-ion battery, which has 12 kilowatts and will power the whole thing, and attached to it has a wireless charging port, which will be able to recharge the battery since it's rechargeable. There are two microchips, as can be seen here. This one, again, controls more so the camera, and this one controls the electrical impulses that will reach the optic nerve. And this is obviously a transducer, which will further help the optic nerve read these signals. The battery is 20 millimeters wide, and both microchips will be between 6 to 8 millimeters. The transducer is about 5 millimeters wide, and same with the wireless charging port. Not shown here are going to be Dacron tabs outside of the glass eye, so that when the surgeons are doing surgery, they could attach the muscles to the Dacron tabs, so that the eye could have lifelike movements. Now we're going on to the conclusion.
But before the conclusion, let's go to the second part of the statistics.
Yes, we've calculated that in total, Eye-Nghin will be 12,000 euros, including all the materials and components, and we will be selling it for 17,000 euros, therefore making a profit of 5,000 euros. And we will be selling it to hospitals and governments in Europe, and hopefully further on it would be sold in America to insurance companies.
And if the entire presentation wasn't convincing enough, I have compiled a short list on why one should choose Eye-Nghin. So, it makes a person feel better and less insecure about their eye, since it's not external and bulky, and therefore they will be more confident in social situations. It is aesthetically pleasing, as the iris can be customized. It is cheaper than competitors, and it has a high-quality camera in order to simulate lifelike vision. And it is also easy to charge via contactless charging through an eye patch with an embedded charger. So as you can therefore see, the device should be the solution to the blind situation. which is why one should choose EyeNghin.